In our previous lecture, we have studied the electric potential due to a point charge. Right now, we will discuss the electric potential due to a group of charges. So, to find electric potential at any point due to a group of charges. Let us consider here are the n charges. This one is the Q1, second one is the Q2, third one is the suppose Q3, and the last one is suppose Qn. And we have to find the electric potential at this point P. And the distance of this point P from this charge Q1 is suppose R1, and the second one is suppose R2, third one is suppose R3, and fourth one is suppose R4, R5, and so on. And for the last let, the distance is suppose Rn. Now we have to find the electric potential at this particular point P due to the group of charges. This one is a group of charges. You can imagine any number of charges. Q1 is the very first charge, second one is the Q2, third one is the Q3, and the last one is the Qn, suppose. Now the electric potential at point P due to the charge Q1 is given by V1, that is equal to K Q1 by R. Here K is the constant for proportionality, and K, you can say that this one is equal to 1.4 by epsilon naught. We will directly use over here the K. Similarly, for the second charge Q2, the potential at point P, that is given by V2, and this one is equal to K Q2 by R2. Similarly, for the third charge V3, that is equal to K Q3 by R3. And at last, for the nth charge, that is equal to Vn, and this one is equal to K Qn by Rn. And this potential is a scalar physical quantity, so the net electric potential at point P, that is the algebraic sum of all these potentials, that is V is equal to V1 plus V2 plus V3 and plus at last Vn. So substituting the each and every value from upper values we have find already V1, V2, V3, V4 in this particular equation, then V is equal to K Q1 by R1 plus K Q2 by R2 plus K Q3 by R3 and so on, at last plus K Qn by Rn. And you can write V, that is equal to K summation, this one is the sum for n terms, and you can write Qi upon Ri. This varies from 1 to n. So this one is the expression for the electric potential at a point due to a group of charges. This one is a scalar physical quantity, so you have to keep in mind the very first thing that charge is the positive, the potential due to the charge is also the positive. If some charge is negative, then the potential due to the charge is negative, so you will add them by using algebra. So the net electric potential, that is the algebraic sum of the potentials at the point due to the various charges. So we can say the potential of a positive charge is positive, and potential for a negative charge is negative. So you have to keep in mind the same, the potential of a positive charge is always positive and potential for the negative charge is always negative. You have to substitute. If some charge is negative, then you have to put the value over here. Suppose this Q2 is negative, then we will substitute the negative value over here, and then we will find the algebraic sum of all these charges. So the expression for the potential is V, and this one is equal to K is a constant summation. This one is the sum of all values, and this I 1 to n, and then Qi upon Ri. So this one is the expression for the electric potential due to a group of charges. Now suppose we have to solve a few numericals based on this particular question. So you can say, I'm writing two examples for this question over here. Suppose I have two charges. Suppose one charge is q1 and the second one charge is q2, and this one is just suppose positive charge, and this one is equal to 2 into 10 to the power minus 6 coulomb, and another one is minus 3 into 10 to the power minus 6 coulomb, and they are to be separated by some finite distance, suppose 15 centimeter. Find the point on the line joining the two charges. Where the electric potential is 0. अभी मैंने आप लोगों को बताया कि पॉजिटिव चार्ज की वजह से जो पोटेंशियल होगा वो पॉजिटिव होगा और नेगेटिव चार्ज की वजह से जो पोटेंशियल होगा वो नेगेटिव होगा। एंड मैंने आप लोगों को प्रीवियस क्लासेस में ये बताया था कि जिस चार्ज का मैग्नीट्यूड कम है उसकी वजह से पोटेंशियल वो कम रहेगा, और जो पॉजिटिव चार्ज का मैग्नीट्यूड ज्यादा है उसकी वजह से पोटेंशियल ज्यादा रहेगा। लेट आई एम कंसीडरिंग हियर फॉर द सॉल्यूशन that is the point on the line where the electric potential is 0. Suppose here is the point P and that this one is at a distance x. So the remaining distance is the 15 minus x. So you can say the potential of this point P is 0. And I told you so the potential due to this plus q charge is supposed to be V1, and for this negative charge is supposed to be V2. And the algebraic sum of these two is 0. So V1 that is equal to K Q1 by x plus K Q2 by 15 minus x. This one is equal to 0, and K, substitute the value for the K1. This one is equal to 2 into 10 to the power minus x minus 6 upon x, and with the sign of minus K because this charge is negative, 3 into 10 to the power minus 6 upon 15 minus x, that is equal to 0. So you can write K 2 into 10 to the power 6 upon x. This one is equal to, writing on the right side, we will get K 3 into 10 to the power 6 minus 6 upon 15 minus x. K से K cancel हो जाएगा, minus 6 से value minus 6 cancel हो जाएगी, then on cross multiplying we will get 3x is equal to 30 minus 2x. So you can write 5x is equal to 30. So x is equal to 6 centimeters. So we'll get from this particular charge the potential of this point P, which is at a distance 6 centimeter from the charge Q1 is 0. The electric potential at a distance of 6 centimeter from the charge two into 10 to the power minus 6 coulomb. Similarly, you can do many more questions on this particular topic. One more example I am writing over here. You are to be given a square with the side A that is equal to root 2 meters. Here is the point A, here is the point B, here is the point C, suppose here is the point D, and the charge at point A is 100 microcoulomb, and suppose at point B that is equal to minus 20 microcoulomb, suppose here that is plus 40 microcoulomb, and here the charge is suppose minus 70 microcoulomb. And we have to find the electric potential at the center of the square. So first of all, we will find the diagonal, and the distance of this point O from the each and every vertex of this square. So you can say OA, I'm writing the solution over here. OA that is equal to OB is equal to OC is equal to OD, that is equal to A by root 2. This one is the standard formulation. I have written many more times for you people that A, it is given to be to root 2 meters and divided by root 2. So we will get OA that is equal to OB is equal to OC is equal to OD, that is equal to 1 meter. So the electric potential at point O, that is the V, and this is the algebraic sum of the potential due to point A, potential due to point B, potential due to point C, and potential due to point D. Suppose V, that is the net potential, and this one is equal to VA, this one is the potential at point O due to A, plus VB, this one is the potential at O due to the charge at B, plus VC, this is the potential at point O due to the charge at C, plus VD, this one is the potential at point O due to the charge at D. So V that is equal to K QA upon OA plus K QB upon OB plus K QC upon OC plus K QD upon OD. This one is the standard formula, and you can substitute the value for each and every charge and for the distance. K is a standard constant, so you can take it out. You can take it the common. So QA, that is the 100 microcoulomb, 100 into 10 to the power minus 6 upon this distance OA is 1 meter. This charge is negative, so I will substitute the value from here. Minus 20 into 10 to the power minus 6 upon 1 again, plus QC, this is the 40 microcoulomb, 40 into 10 to the power minus 6 upon 1, and this charge QD, this is the negative charge again, minus 70 into the 10 to the power minus 6 upon 1. So you can say V that is equal to, substituting the value for the K is a constant, standard constant, I will write 9 into 10 to the power 9. This 10 to the power minus 6 is also the constant, so you can say 100 minus 20 plus 40 and plus 70. On solving all these values, this and these are plus 140 and this one is minus and the minus, here is also minus, these two are of minus 90. So 140 minus 90, so we'll get 50. So you can say V that is equal to 9 into 10 to the power 9 into 10 to the power minus 6 into 50, and this one is the answer is involved, and you can solve this equation right now. So this is the electric potential at the center point, center of the square, and V that is equal to, on solving the powers we will get plus 3 plus 4, 45. 45 into 10 to the power 4 volt. So you can solve each and every question like this. You have to add them algebraically because this potential is a scalar physical quantity.